Welcome to Chemistry World. In previous video, that is in part 3, we have discussed about 7 basic units to measure physical properties of a chemical substance or substance or object. In that, first 4 are important. We have seen in that. Now, let me discuss in this video the derived units used to describe the physical properties of a substance. Derived units, why we call these are derived units means these can be these physical quantities these physical quantities are derived from derived from 7 basic units derived from 7 basic units 7 basic units. These are derived from 7 basic units. That's why we'll call it as derived units, because these have been calculated from 7 basic units. In that, the first derived unit is volume. The first derived unit is volume. Length is basic unit, because one dimensional size of substance occupying space. Volume means three-dimensional space occupied by the substance. It will be derived from the formula length into breadth into height. Length into breadth into height. Length into breadth into height. So simple formula L into W into H. In some books that will be derived as W. Generally, length will be measured in according to SI units. Length will be measured in meters. Breadth also measured in meters. Height also measured in meters. So it will be m cube. Meter cube is SI unit for measuring volume of a substance. Meter units will be used. I am saying only SI units. I am not going to other types of units like CCS and other types of units. Only SI units. Let me stick to there only, because we require only SI units. That's why I am taking. Volume is one of the derived unit. It has been derived from the 7 basic units. Length into breadth into height is nothing but L into W into H. Generally, breadth will be measured by using W. So L into W into H is called volume, and units, SI units of length is meters, SI units of breadth is meters, height also meters. So the volume units are meter cube. And second derived unit required for chemical substances is area. It is also derived unit. Length is fundamental unit, basic unit, but area is calculated by the formula we know, length into breadth. Length into breadth, that is L into W. The units meter into meter equal to meter square. Meter into meter equal to meter square will be used to identify area. It is 2-dimensional size. It is 3-dimensional size of the substance. Length is 1-dimensional size. Next, the third derived unit is density. Third derived unit is density. The symbol of density is small d or capital D, that depends upon that one. So it is calculated by the formula mass by volume. mass by volume. Density will be measured by mass, derived by mass by volume. Mass is basic unit, but volume is derived unit. From this, it will be derived. Density will be derived. So the units, if you say for density, mass SI units is kilograms, volume units are meter cube. That's why we can say kilograms per meter cube. We can say. Generally, density will be given in CGS units, grams per cc, but better to use that, convert that into kilograms into meter cube, because grams per cc we should not use for numerical calculations. SI units are kilograms per meter cube. Like that, we have next properties. Acceleration is one of the derived unit that will be calculated by the formula velocity by time. Next, force will be calculated, that is mass into acceleration, then pressure. Next, fourth one is acceleration is one of the acceleration is fourth unit. It is derived unit. It will be calculated by the formula velocity by time. Velocity by time. The units, if you say for acceleration, meters per second, and for time, second will be there. So meters per second by seconds will be there. From this you can say meters per second square are the units for acceleration. We require in chemistry also, we require acceleration. That's why I'm taking is a fourth derived unit. First derived unit is volume, second derived unit is area, third derived unit is density, fourth one is acceleration, then fifth one is force. Force also a derived unit. The symbol for this is F. Capital F or small f, that depends on the requirement. We can use force. It will be calculated, it will be derived from two units. One is mass into acceleration. Force equal to mass into acceleration. Mass into acceleration. That is called force. The units for force will be units for mass units are kilograms, acceleration units are meter per second square. So force units becomes kilograms, meters per second square. So kilograms into meters per second square are units for force. Kilograms, meters per second square are units for force. Must and should, must and should, must and should, must and should. And sixth property is sixth derived one. Most important we require is pressure. This is also derived unit. For chemistry, in in chemistry, we must require pressure unit. That's why it is a physical quantity. So that will be derived, will be derived from other units. So pressure. Pressure is nothing but force by area. The symbol for this pressure is P. P equal to force by area, means the pressure unit has been derived from this formula, force by area. So units, if you say for force, I'm removing this one. For force, units are kilograms, meter per second square, and area units are meter square by meter square will be there because area units meter square. That's why I'm not remove this one. So pressure equal to force by area. So in that, if you cancel these two, remaining units are kilograms meter inverse per second square. Meter inverse second square inverse. Kilograms meter inverse second square inverse are the units for pressure. Atmospheres bar other units are there, but in SI system, atmosphere is not the SI system. Remember, SI units for pressure is kilogram meter inverse second square inverse. Kilograms meter inverse second square inverse, and the remaining derived units are energy, work, electrical charge, electrical potentials, all also there, but we doesn't require in chemistry. Mostly we require these properties. 6 derived units we require. Other are there. Once again I'm saying work is there. Of course work also we required, that is force into distance we have. Let me take that one also. Seventh one, work. This is also a physical quantity. It will be calculated. The symbol for this work is W. It will be calculated by the formula force into distance. Force into distance is nothing but work. Force into distance. And if you calculate the units, force units are kilograms meter per second square into distance always will be there in a meter. The distance in SI units are meter. So meter, it becomes meter square. So then work units are kilograms meter square per second square. Please be very careful. These 6 density units are this. Density units are this. Volume units are this. This is 1 volume, and area units are this. A I am writing meter square. This is equation 2. And third one, density units are this. This is equation 3. Accelerator units are this. This is equation number 4. And these are 5. And this is 6. And this is 7. These are 7 derived units. 7 basic units, 7 derived units are enough for us for physical properties discussion of a substance. So to know the behavior of a substance, we should know 2 types of properties: chemical properties and physical properties. Chemical properties can be measured based on the chemical reactions, but physical properties will be measured based on the physical measurements. In that physical measurements, we have 7 basic units, and we require 7 basic units and 7 derived units. In that 7 basic units, 4 basic units: mass, length, time, temperature we require for chemistry. That's why that 4 only I have explained. Then these 7 derived units we require: volume, area, third one density, fourth one acceleration, fifth one is force, sixth one is pressure, seventh one is work. So for volume, the units SI units are meter cube. For area, SI units are meter square. For density, SI units are kilograms per meter cube. For acceleration, the SI units are meters per second square. For force, SI units are kilograms meter per second square. For pressure, SI units are kilograms meter inverse second square inverse. And for work, SI units are kilogram meter square per second square. Kilograms meter square per second square. These are we require for physical properties measurements. Physical properties measurements. After that, let me go for conversions of units and all these things. Conversions we require. Let's go for conversions. Conversions means these are very important. What are the conversions and all these things? Let me go for. So I think this is basic idea of the physical units we have seen. Let's go for conversions. How to convert area, that is SI units into CGS units, CGS units into SI units, because so many types of units are there for each physical measurement. Physical quantity measurement, not only SI units will be there. In question paper, we may give CGS units also, other units also, but we need to convert that into SI units. How to convert that other units into SI units or SI units into other units? Let me see now. That is called conversions. Conversion of units also we can say. I'm removing if you require this one, and you can write by pausing the video. Now let me see the conversion of these units. Conversion means other units into SI units, SI units into other units, like that. How we convert? Let me see now. This is very important. The conversions, if you are very perfect in conversions, of course in school levels also it will be there, but once again, for chemistry purpose, what are the conversions we require? That I am explaining here only for chemistry purpose. I am not going to other conversions. What we require for chemistry purpose calculations in chemistry subject, that only I'll explain. That is conversion of units. Conversion of units. Let me see about these topics. Conversion of units. Conversion of units. First one, we know units for time. The first one, the time. Time may be given in hours, minutes, days, months, years, and seconds. But whatever the time he has given, we have to convert that into seconds. We have to convert that into, we should not use directly for calculation purpose in physical measurements. We have to convert hours into seconds, minutes into seconds, days into seconds, months into seconds, and years also into seconds. Of course, if he has given the answer in years itself, you can use directly years. If months are given in the question and months also there in the answer, that is in 4 multiple options, so you can. If he has not given any units, compulsory you have to convert that into seconds. Don't use directly. So we know 1 minute equal to 60 seconds. 60 seconds, and 1 hour equal to 60 minutes. All these things are there. You can convert easily by using. I'm not saying that, I'm not going to, because everyone know that one, how to convert hours and minutes and dates into seconds. But remember, whenever he has given the time in these things, don't use directly. In the options, if it is there in the question, if it is asking directly by giving hours and asking in hours, by giving minutes, asking in minutes, by giving days, asking in days, by giving months, asking, you can use direct. But if is not given anything, but in the question hours, minutes, days, months and years are there, don't use directly. Convert that into seconds. Compulsory you have to convert that into seconds. That is first one. The second conversion is, the second conversion is length conversions. Second conversions is length conversions. Most of the questions we require conversion of lengths. Generally, I already told you in SI units, the length will be measured in a meter because it is one dimensional. So the units of length is meter. But in chemistry, that much of substances will not be there. Meter length substances will not be there. That may be there in a mostly angstroms. A dash means angstroms. A dot, or also we can say mostly they will give in angstroms, and mostly they may give in nanometers. Nm means nanometers. They may give in picometers. They may give in mostly in chemistry we have this one, angstroms, nanometers, picometers. So whenever he has given in these things, don't use directly. We have to convert that into meters, whether he has given in angstroms, whether he has given in nanometers, whether he has given in pico. Mostly they will use these three. You can see any question regarding the size or regarding the length, that will be there, angstroms, nanometers, picometers. Mostly picometers and angstroms are most important. Of course, nanometers also important, but in this, most probably these two will be there. And we know 1 angstrom equal to 10 power of minus 10 meters. Why? Because 1 meter equal to 10 power of 10 angstroms. 1 meter equal to, why we are saying this means 1 meter equal to 10 power of 10 angstroms. If you want to convert angstroms into meters, this is the formula. If you want to convert meter into angstroms, this is the formula. Conversion of meter into angstroms is 10 power of 10. Conversion of angstroms into meters is 10 power of minus 10 meters. 1 angstrom equal to, and 1 picometer equal to, 1 picometer equal to 10 power of minus 12 meters. 10 power of minus 12 meters. Why? Because 1 meter equal to 10 power of 12 meters. I'm sorry, 10 power of 12 picometers. So that's why if you want to convert picometer into meters, 1 picometer equal to 10 power minus 12 meters, or 1 meter equal to 10 power of 12 picometers. 10 power of 12 picometers, like that feeling. And based on this, you can say 1 picometer from this, and from this, if you want to take the relation from this and this, 1 picometer equal to 10 power of minus 2 angstroms, or 1 angstrom equal to 10 power of 2 picometers, because it's 10 power minus 10 into 10 power minus 12. So like that we have 10 power of 2 picometers, or 1 picometer equal to 10 power of minus 2 angstroms. Nanometer, and 1 nanometer equal to 10 power of minus 9 meters. Why? Because 1 meter equal to 10 power of 9 nanometers. 10 power of 9. So 1 nanometer equal to 10 power of minus 9 meters. And if you see the relation between angstroms and nanometers, 1 nanometer equal to 10 angstroms, and 1 angstrom equal to 10 power of minus 1 nanometers. So these are important conversions. These are important conversions we require in the length. Must and should we have to convert. Angstroms, nanometers, picometers, these three are major conversions we require. So 1 angstrom equal to 10 power minus 10 meters, 1 picometer equal to 10 power minus 12 meters. From this, 1 picometer equal to 10 power minus 2 angstroms, or 1 angstrom equal to 10 power of 2 picometers, and 1 nanometer equal to 10 power minus 9 meters, 1 meter equal to 10 power of 1 nanometer equal to 10 power minus 9 meters, 1 meter equal to 10 power of 9 nanometers. And the relation between angstroms and nanometer, 1 nanometer equal to 10 angstroms, 1 angstrom equal to 10 power of minus 1 nanometers. Like this, You have to use these compulsory conversions are required. Without that, you cannot convert, you cannot use all these things. Next, conversion of liters atmospheres into joules, that is also very important, that is pressure conversion. Next important for chemistry is pressure conversion. Generally, in SI units, I wrote pressure units are kilograms, meter square per second square. We wrote now. So here, mostly the pressure will be measured in atmospheres. Mostly pressure will be measured in atmospheres, and volume will be measured in liters. So conversion of liters atmospheres into joules. Third one is conversion of liters atmospheres, liters atmospheres into joules. Let me write here into joules. Liters atmospheres into joules. So 1 liter equal to 10 power of minus 3 meter cube. First thing you should know. 1 liter equal to 10 power of minus 3 meter cube. Because in SI units, volume will be measured in a meter cube, and liters also another type of units. 1 liter equal to 10 power minus 3 meter cube, and 1 liter atmosphere equal to 1 liter atmosphere equal to 1 liter atmosphere equal to 10 power of minus 3 meter cube and atmospheres. 10 power of minus 3 liter cube and atmospheres. Then 1 atmosphere pressure equal to 101 325 pascals. 101 325 pascals. Pressure units, pascals also units of pressure. 101 325. So if you write that into liters atmospheres, 1 liter atmosphere equal to 10 power of minus 3 meter cube into 101.101325 pascals. 101.325 pascals. 10 power minus 3, 101, we can write here point. From this, what you can write is 1 liter atmosphere equal to 101.325 meter cube pascals. Meter cube pascals. 1 liter atmosphere equal to 101.325 meter cube pascals. 1 liter atmosphere equal to, so 1 pascal equal to, actually 1 pascal equal to 1 newton per meter cube. 1 newton per meter cube. So then it will be, if I divide that one with that, 1 liter atmosphere equal to 1 liter atmosphere equal to 101.325 newtons per, because newtons are there, meter cube is there, meter cube will be cancelled out. So newtons meter will become, newtons meter, nothing but joules. So 1 liter atmosphere equal to 101.325 joules. 101, because 1 joule equal to 1 newton meter. 1 newton meter. So 1 liter atmosphere equal to 101.1 liter atmosphere equal to 101.325 newton meters or joules. This is very, very, once again I am saying, conversion of liters atmospheres into joules is we require, that is very important. How we have to take this one, why we have to take 101.325 means, reason is this is the basic, that's why I'm saying 1 liter equal to 10 power minus 3 meter cube, 1 liter atmosphere equal to 10 power minus 3 meter cube atmosphere. Meter cube atmosphere. 1 atmosphere equal to 101,325 pascals. So 1 liter atmosphere equal to 10 power minus 3 meter cube into 101,325 pascals. 10 power minus 3, and if I divide this one with the 1000, you will get 1 liter atmosphere equal to 101.325 meter cube pascals. 1 pascal equal to Newton per meter cube. So then 1 liter atmosphere equal to 101.325 newtons meter. 1 newton meter equal to 1 joule. So 1 liter atmosphere equal to 101.325 joules. 1 liter atmosphere equal to 101.325 joules. Like that, you can convert liter atmospheres into joules. That is very important in chemistry for intermediate level. These conversions must ensure. Without these conversions, without knowing this one, it is very difficult. That's why these are the bridge course concepts, conversions. In the future, the lecturers will go directly to convert, directly conversions. They will not use all these things, how we are getting, why we are getting, all these things they will not express. So please be careful. You can easily understand by all these things. Go step by step. Don't see directly all these things. So I converted time, length, and liter atmospheres into joules. These three conversions I told you. Okay. Next basic that we see in a part 5. So thank you.